Previous session we dealt with the calculation of molecular weight, equivalent weight. From there we calculated the molality and normality. So now we are going to see the overall formula for molarity. So molarity, number of moles of the solute divided by volume of the solution. So why we are saying solution or solvent? Because the moment the solute dissolved in the solvent, we call it as a solution. Because for example, when they say 1 mole in 1 liter, so what we have to do is, so first we have to take 1 mole of weight of that component, then we have to pour it in a standard measuring flask. Then only we have to make it to 1 liter, because it has certain mass. So mass also it can displace a little amount of volume, right? So you can't take something like, for example, if I have 40 gram of NaOH, I can't directly take 1 liter. So first 40 gram I have to put it, I have to add little amount of water, then only I have to make it to 1 liter. So that's why we call as a solution. So the formula is number of moles is N, the given volume is V in terms of in volume in ml. So it is N by V into 1000. So number of moles are weight by molecular weight into the remaining 1000 by V carries. So similarly for the molality, here number of moles of the solute divided by weight of the solution. So it's a mass by mass. The first one is mass by volume. So number of moles of the solute divided by weight of the solution into 1000 in terms of weight is in terms of grams. Okay. So the total formula comes, number of mole is weight by molecular weight, the 1000 by W. The small w is for the solute, capital W is for the weight of the solvent, or sometimes we say the moment the solvent touches the solute, we call it as a solution. Normality, so as we know, we calculate the number of gram equivalents of the solute divided by the volume of the solution. It's a volume of the solution. So it's a gram equivalence by volume into 1000. So what is gram equivalence? Given weight by the equivalent weight into 1000 by V. Okay, so formality we generally don't use, because formality is little bit similar to molarity or normality. For ionic compounds, it has some multiple unit cells. So we don't take like 1 mole, we have to take one formula weight for 1 unit cell, like how many formula of the ionic compound is coming. So for example, NaCl has many repeating units in the crystal lattice, right? So we have to take the formula mass of the given ionic substance, that is the solute, and volume of the solvent or solution. So formula mass divided by volume into 1000. So formula mass is weight by given that either molecular weight of the given formula unit, okay, into 1000 by V. And mole fraction, so mole fraction, for example, if you have I have salt and water, okay, so there are two components, so it is going to make the solution, right? So I have to calculate the how many number of moles of salt is there, how many number of moles of water is there. So when I calculate individually all the moles for each component, then when I submit it, I will get the total number of moles. So if I want to calculate for the salt, what is the salt moles divided by the total moles. So similarly, number of moles of the given component divided by total number of moles. So total number of moles is here for two components, Na plus Nb equal to total N, and you have to take the fraction of that given. Xa means Na by total moles, Xb means Nb by total moles. Suppose if I have totally 3 components, so I have to calculate N equal to total N equal to Na plus Nb plus Nc. That is my total moles, and the given moles are Na by N, Nb by N, and Nc by N. So you can calculate how many other components are there. So total moles you have to sum it up, then you have to take the ratio of given moles of the given component divided by the total moles. So that's all about the mole fraction. Next what we are going to see is the percentage of the solution. So these are mostly we use in the chemistry lab. So percentage of the solution we use it in the biological biological lab, so they'll be preparing all the solution in terms of percentage. Okay, so first we'll see the percentage of the solutions. So there are three types of percentage of the solution. So first we are going to take the volume by volume percentage. So what is that? Given volume of the solute divided by volume of the solution, that is solute plus solvent. Okay, volume of solute plus volume of solvent. Suppose if I have 20 ml of ethanol, I have to make a 1 liter, for example. So remaining how many mLs I have to add? I have to add 980 ml of water, okay, for 1 liter. So if they are not given, so like for 1000 you have to make it whatever the given ml is, just you have to sum it up. That is the total volume of the solution. What is solution? I said solute plus solvent is the solution. So this is the volume by volume ratio into 100 you have to put. Okay. Second one is the weight by volume percentage. So weight of the solute or given weight of the solute divided by volume of the solution. So the moment you have to take that amount of the solute as well, so that will make solution, that will be into 1000. Next one is weight by weight percentage. Weight of the solute divided by weight of the solution into 100. Okay, so these are percentage solution. Finally what we have is the ppm. Okay, ppm is mass of solute volume of the solution into 10 to the power 6. Okay, so this is like 1 part in million, 1 part in per million. For example, it's like I have to take 1 milligram in 1 liter. 1 milligram of the solute in 1 liter, we call it as a parts per million. So the mass of the solute divided by volume of the solution or weight of the solution into 10 to the power 6 times. So this we will use in the finding out the hardness of the water, like parts per million, how much calcium ions are there, how much chloride ions are there. So to calculate in water, so we call it as a parts per million. Then 1 demol. Demol is when you calculate a mole per liter at 1 mole in 1 liter at 0 degree Celsius is known as demol. So these are the various types of concentration terms that comes in the solution lesson. So hope you understood. So we will work out the problems in the upcoming session. Hope you understood. Thank you.